This is a relatively advanced session. I'm going to be covering a lot of different topics around architecting your deployment of ArcGIS Enterprise. Many things go deep and then also very broad. So I want to get a feel for everybody in the room. Do you think of yourselves primarily as developers, GIS analysts, IT administrators? So developers. This is the Dev Summit after all. All right. IT administrators, meaning you're responsible for installing, configuring, running the software. So those of you who had your hands up for both of those, do you consider yourselves more of a DevOps type shop, or is it, no, I just wear many hats? DevOps? Many hats? Lots of people with many hats. Job security. So this session is definitely geared toward the IT administrators in the room. For those of you who don't feel like that's necessarily you, I hope you still stick around. It's okay. Hopefully you'll hear about a great many different concepts that you can use to gain a better understanding of your actual implementation or your future implementation, or simply work better with the IT people within your organization about what is it we need to do. There's all this software. Esri keeps releasing new software and new components. You need help getting it all set up. So that is the target audience for what I'll be talking about here for the next hour or so. My name is Heede. I'm the lead product manager for ArcGIS Enterprise. I moonlight as somebody also knows what he's talking about technically. With me is Shannon here down in front, also product manager on the ArcGIS Enterprise team. So afterwards, we'll do plenty of questions at the end if I don't go too long, but afterwards come up and talk to Shannon and myself and we'll try to answer your questions. We'll also be in the showcase later on. All right, with that said, like I mentioned, I'll be covering a lot of different topics in a decent amount of depth. So don't panic. If you feel overwhelmed at the end of the session, it's a little bit by design. I want you to know a lot of things about a lot of different things. But I also want you to know that you should go and follow the documentation. Don't think that you can just sit down and necessarily go through all of these topics over the course of 1 hour and now you're going to be an expert. I cannot make you an expert. What I want to do though is make you aware of all these things so you can go back and find the information you need. Hopefully there's also going to be a lot of good information on the slides themselves. A lot of information that is in the documentation, but maybe just be collected up a little bit more easily accessible here. So when the slides are made available on the conference website here in a couple of weeks, you can also go find those. You're also free to take pictures, although I will give you the slides. All right. How many of you attended any of the Introducing ArcGIS Enterprise sessions or similar ones? If you're following me around, I apologize. I will repeat myself a little bit. For those of you who didn't, I just want to quickly go through some of the ideas within ArcGIS Enterprise, the different software components. I'm going to assume that most of you, if not all of you, are existing ArcGIS for Server customers, users of Server. So you're probably very familiar with the ArcGIS Server software component itself, as well as the web adapter. Web adapter's been around since 10.1. ArcGIS Enterprise is, first of all, the new name for ArcGIS for Server. We don't have to say for anymore. ArcGIS Enterprise flows a little bit more smoothly. And it is a product that contains multiple different software components, specifically 4 software components. There's, of course, ArcGIS Server itself. It has not gone anywhere. Still there, don't worry. Portal for ArcGIS is another key component of the product. And then, of course, there are some of the supporting components like the web adapter that you're familiar with, and also ArcGIS Data Store, which has been around for a couple of releases. But depending on where you are with your deployment, you may or may not have started using it. ArcGIS Enterprise at 10.5 is fundamentally designed to use all 4 of these components together. So that's the first thing that I will talk about here, which is the ArcGIS Enterprise-based deployment. But like I mentioned, all 4 of these components have been around for a while. They're not new at 10.5. But depending on your deployment, they may be new to you. A new thing at 10.5 was also this idea of server roles. Just like users can have a role within the system, servers can have a role within the system. There's a single software component called ArcGIS Server that, depending on what license you apply to it, gains different sets of capabilities. That's a new concept at 10.5. Specifically, I'll be talking about these 4 different sets of capabilities. There's the GIS server itself, which is probably what many of you think of as just traditional ArcGIS server capabilities. Map services, feature services, geocoding, geoprocessing, and so forth. And then we have GeoEvent, image, and GeoAnalytics servers. But the key part here is there's just one thing you install. You download ArcGIS Server, that's the installer, you click next, next, next. Maybe you even use something fancier like Chef Automation or something to install everything, but you install this component, you give it a license, and then it gets a purpose in life. Now it can do certain things. So I'll talk about the individual server roles and how to think of them when you're architecting your system. What are the specific recommendations unique to the individual server roles? Because they're not all the same. There may be one set of bits and bytes written on disk, but they do very different things and behave in very different ways. So one software component, multiple server roles. Let's start with the base deployment of ArcGIS Enterprise. It consists of these 4 components. So gone are the days of standalone servers where you just install ArcGIS Server. Now many of you will say, well, but that's what I have, and that's okay. But ArcGIS Enterprise, beginning with 10.5, is fundamentally designed for the newer capabilities to come in through the base deployment and then adding additional capabilities as you need to the base deployment. The ArcGIS Server component has a key part to play in the base deployment. It's what you set up as what's known as the hosting server. So when you or your users hand over data to the system, whether it's dragging and dropping a CSV file onto a map or performing analysis within the portal, that data has to go somewhere, that result has to go somewhere. And ultimately it has to be hosted by something. The hosting server, that's what it does. So this is where all the services that come through actions within the system are actually served out of. There's a REST endpoint that's coming out of the hosting server. Hosting server is also just a traditional GIS server itself. So you can also publish your own traditional services from data that you're referencing as opposed to handing over copies to the system. So it plays a couple of different roles here. The next component is Portal for ArcGIS. Many of you will probably think of Portal for ArcGIS as that web app, the home app as we often call it because it's /home in the URL. It is of course that, and it's a location that you can use directly as a user. But it's certainly also the back-end infrastructure that powers all of our applications, all of the applications that you build on top of the ArcGIS platform. This is where the group and sharing mechanism also comes in. Identity, access control, and authorization is handled at this tier. Then we have the ArcGIS data store. Like I mentioned, when there we go. When data is handed over to the system, it has to go somewhere. So the ArcGIS data store is a software component that we built for that purpose. ArcGIS data store comes in 3 different types, each designed for different types of data. So typical feature data, that CSV file, the results of your analysis that created vector data output, goes into the relational data store. Think of this as the logical equivalent of a managed enterprise geodatabase. It just happens to be a component that comes with the system. So there's not another RDBMS that you have to explicitly manage yourself. We come with that component because we can make a lot of assumptions about how that component works. We know exactly what the software is, the configuration, because the system manages all of that for you. The second type of data store is the tile cache data store. And despite its name, it's not raster tiles. In fact, it's 3D tiles. When you publish out your own multi-patch data or other types of 3D data that we support these days as scene layers and create web scenes, internally we build a tile cache off of that 3D data. That's what goes into that data store type. And then finally we have the spatio-temporal big data store. This is where things like GeoEvent Server can archive large volumes of data. It can ingest data at a speed far beyond what a traditional RDBMS can do. And it's also where GeoAnalytics itself can write the results of GeoAnalytics output too. So all three of these different data store types have a specific mission and purpose in life. And finally, we have ArcGIS Web Adapter. This is a well-known component for most of you, I would assume. It's where we do certain types of security integration. IWA, PKI, all the web tier security relies on the web adapter. It's also a simple software load balancer. So you don't necessarily have to have your own fancy F5 hardware load balancer or something along those lines. We provide a load balancer with the system. The base deployment is described in our documentation. So if you go to the new 10.5 doc, you can go and see all of the things that I just talked about laid out. Here are the different components. This is what they do, this is what it means. And I strongly encourage you to use this documentation whenever you can. Let's go through the individual choices you have when choosing how to set up your base deployment. ArcGIS Enterprise has a very flexible deployment pattern. It can be installed in basically any software environment where you meet the system requirements itself. That's on premises, in your data center, under your desk, in the cloud, private or public cloud. I won't talk about that here in this session, but I do want to make the point that you don't necessarily have to think of ArcGIS Enterprise as being the on-premises solution, and ArcGIS Online is the cloud solution. ArcGIS Enterprise runs very well in the cloud. In fact, it's much, much easier to run in the cloud than virtually anywhere else. What you do need to make a choice of, no matter what environment you're running within, is do I want everything on a single machine? That's simple. Or do I want a multi-tiered deployment? Do I install my portal on one machine, my server on a second machine, my data stores on a third machine, or maybe a fourth machine? How many machines do you have? How many machines do you want? How many do I need? That's choice number one for the base deployment. No matter what particular deployment pattern you choose, it's the same logical architecture. There's a web adapter for the portal, there's a web adapter for the server side, and then you have the ArcGIS data store. So when is it appropriate to install everything on one machine? Many times this can be dev test environments. That's very simple and easy to get started with. But it can absolutely also be appropriate for small production environments. It doesn't have to be that as soon as you have a production environment, you install everything on multiple tiers. If you're a small shop with a limited amount of users or simply big machines, you can and are perfectly fine running everything on one machine. So when do you need to go multi-tier? Well, one of the challenges is that you may at some point have to scale out. And it's much harder to start scaling out if you've already installed everything on one machine. Because now you have to start scaling out the individual tiers and you have to break things apart. So that's the first thing that I want you to think about when you first start looking at ArcGIS Enterprise and your deployment pattern. Do I ever need to scale out in the future? And maybe that's a hard question to answer. But nonetheless, if you suspect that you may have to, that's an indication you might want to start looking at a multi-tier deployment from the get-go. So setting up the base deployment, there's a number of different steps. You have to install all the software, and then all the software has to get configured together. All those deceptively simple lines between the components, Yes, you get to do that. So what's the first step? Well, after installing all of your software, a key part is to designate your hosting server site. You've installed ArcGIS Server, you federate that ArcGIS Server with Portal, and then you tell the portal, this server site is going to be my hosting site. So Portal knows this is where I send all of that hosted data that gets copied over to the system. Before you can do that, you need to configure the ArcGIS data store with your server site. You need to install the relational data store and the tile cache data store. Now, that sounds complicated. I don't want to scare anybody off though. We have a tutorial. So you can go again to the documentation. This lists out every single step that I just talked about in detail, step by step, for an all-in-one deployment. So this, on a single machine, you're setting everything up if you follow this tutorial. If you want to follow this tutorial for a multi-tiered deployment, it's not a huge leap to simply think of all the components on separate machines. If you're running in the cloud, like I mentioned, it's even easier. We have CloudFormation templates for AWS that does exactly this for you, and we have the Cloud Builder for Microsoft Azure. And it is literally going through a wizard in the Cloud Builder saying, I want one of these, I want it on one machine, I want it on multiple machines, walking away for half an hour, 40 minutes, go to lunch, and it'll have done everything for you. So there's lots of options for how to get all of these things set up and installed, but at the end of the day, whether you do it by hand or through one of our automated options, you have a base deployment in place for you to work with. So when we talk about the different capabilities of ArcGIS Enterprise, that is referring to what you can do with the base deployment in place. There's additional capabilities that we can add to the base deployment using the other server roles, such as GeoEvent, Image, and GeoAnalytics. Lots of things that we've built over the past couple of releases fundamentally requires the base deployment. All of you are most likely publishing your services from ArcMap today. Over the past couple of releases, we've added the ability to publish services from ArcGIS Pro. ArcGIS Pro has a lot of new functionality. Parameterized query layers, display filters, great things that you've been asking for over the past several years. Pro publishes to ArcGIS Enterprise, not standalone servers. So that requires the base deployment to be in place. Pro works with federated servers, so everything is tightly integrated with identities and access control in one place. So once we have the base deployment in place, when do I need to scale out those individual tiers, the portal tier, the server tier, the data store tier? So let's take those one at a time. The portal tier is fairly simple. You very rarely have to scale it out. Portal is not very CPU intensive. It uses a fair amount of memory depending on your usage patterns, the amount of users and so forth, but that's really about it. It's not a super heavyweight component. Portal supports having a highly available environment, meaning two different machines handling the load, so if one of them goes down, the other can automatically take over. But the way to scale Portal is to simply scale up the machine that it's running on, adding more memory or adding more cores if you truly run into bottlenecks at that level. You don't add additional machines for additional capacity like you would with ArcGIS Server. With ArcGIS Server, you have a couple of different options. And these are the same options that you've had with the server component since 10.1. Things have not fundamentally changed for a while in how you do this. You can, of course, scale up. You have a single machine, you need more capacity, just add more capacity to that single machine. If we're talking physical machines, that may not be so simple. If we're talking virtual, you may simply be able to increase the size of your VM. But of course, you can also scale out. So instead of just scaling up, scaling out by adding multiple machines to your site. All of the machines within a single ArcGIS server site perform the same duties. They have the same services published to them. You're simply adding additional capacity. So when requests come in, they can be spread out over multiple different machines. You can scale out ArcGIS Server with n number of machines, however many you need to support whatever the services you're publishing and the load that you're pushing on it. So specifically for the base deployment, the hosting server is an interesting thing because it's not just your services, things you have explicitly published using ArcMap or Pro. It's also all of the things that users are doing within the system, such as performing analysis. Beginning with ArcGIS 4 server at the time, 10.4, we had the out-of-the-box analysis tools. Users can go within the map viewer in the portal and simply perform analysis, simple GIS analysis in there. Well, that analysis has to happen somewhere. That's what fundamentally, again, what the hosting server does. So now we have what amounts to GP jobs running on the hosting server. If you have a lot of users running a lot of analysis, you will need to look at your hosting server site and make sure you have the appropriate capacity. New with ArcGIS Enterprise at 10.5 is Insights for ArcGIS. You've seen that demoed on stage here on Tuesday. Insights is a fantastically cool and new type of web application, but it's not just a pretty JavaScript app. It has a server backend component to it. That server backend component runs on the hosting server. So you need to be aware of the load that you're putting on the hosting server for the actual number crunching that happens within Insights for ArcGIS. So when do I need to scale out the ArcGIS data store tier? ArcGIS data store, like I said, has 3 different data store types within it. And they need to be scaled for different reasons. The relational data store, that's where data from hosted feature layers goes. Again, that CSV file that somebody dragged and dropped onto a map within the portal map viewer, that goes into the data store. So it's an interesting thing that we can scale massively in the number of hosted feature layers. If you're long-term server users, server administrators, you'll know all about ArcSoc processes. They use a lot of memory, don't they? Nods, yes. Hosted feature layers don't. It's a fundamentally different architecture, different backend implementation. It doesn't use the SOC processes, it's simply Java code that we're running. But the way that Java code works is that, well, we rely on the database to do a lot of the heavy lifting. We're just streaming data back. So you need to understand that even though you may have 10,000 hosted layers, that's not using a lot of server memory on your hosting server itself, but the backend database may be doing a lot of work to try to keep that data within memory and so forth. So you need to monitor your data store, your relational data store, for memory usage. If you have a lot of users using a few set of services, hosted services, that is optimal because that's fundamentally what the system is designed for. Out of 10,000 hosted layers, the odds are there's only a fraction of them that are actually in hot use at any given point in time. But the more of those services that are actually in use, the more there's memory and CPU consumption at especially the database tier. So something to be aware of and something to monitor. As you open up self-service mapping to your organizations and lots of those services are generated, be aware of this tier and what is going on there. The key thing is to always monitor for bottlenecks. The tile cache data store, like I mentioned, is used by scene layers or 3D data that you publish out. During the publishing process, there's 2 things that happen. The data gets handed over to the server, well, to the system. The server starts crunching through that data to build a tile cache. At the point in time of publishing your scene layer, that takes up CPU on the hosting server itself. But once it's built, it's just like a cached map service. Static data that's now being stored and streamed back to clients upon request. That data goes into the tile cache data store. So that's where you start seeing memory consumption on the tile cache data store. If you have a lot of different scene layers that are all being actively used, they're all hot in memory, you will need more memory on the tile cache data store tier. So now we have a base deployment. You don't need to scale the portal tier very often. You need to be aware of what's going on at the hosting server tier, and then you need to understand what's going on at the data store tier. Now we go beyond that. And there can be lots of different reasons for why you need to go beyond the base deployment. One is, I already have the GIS server, but it sounds like I want to isolate certain features, certain services from the hosting server itself. Workload separation. Let's say I have a lot of insights users. I don't want my other map services, the ones that are powering the rest of the organization, to be impacted by when somebody performs analysis within insights or within the portal itself. That sounds like a bad deal. You can add additional GIS server sites to your deployment. And you don't have to stop at one additional site. Lots of you have multiple sites one for map services, one for a different set of map services maybe, one for geoprocessing services because, well, GP can be heavyweight by itself. Isolating those things from each other is up to you as system architects to understand your particular usage patterns and when does it make sense to create a separate site for certain features. You have the flexibility to go all in one or spread across as many different sites as you want and feel you can actually maintain. There's of course trade-offs. And then another reason to add additional server sites to your ArcGIS Enterprise deployment are for those additional capabilities. The image server, GeoEvent, and GeoAnalytics. Those are all designed to be set up as separate sites. Now at this point, I often get the question, well, can I have some of those other server roles on a single site? Maybe on the same site as my hosting server, maybe just commingled with a GIS server. The short, technically correct answer, which as developers you appreciate that, is yes, you can. The longer answer is don't. The even longer answer is don't unless you really know what you're doing. So fundamentally, GeoAnalytics server should never be put on the same machine as anything else. GeoAnalytics server sucks up every single resource it can get its hands on because that's what it's designed for. All the memory and all the CPU you can possibly give it. GeoEvent server has a similar type of pattern. It uses a lot of CPU potentially for all those events streaming into the system. So generally, you would not want to combine GeoEvent with anything else. Now once we get to image server, as we'll see in here just a second, there's a little bit more wiggle room. But in general, image services, traditional image services, have a tendency to also be CPU intensive depending on what you're doing with them and the amount of data. It's a very good candidate for workload separation, and unless you have very good reasons to and really truly know what you're doing because you've tested it out ahead of time, I would not recommend putting it together with any of the other server roles. So let's dig into the different server roles. First, I want to just make the point that you can have many federated sites within a single deployment. It's a common misconception, or at least a question I hear fairly often is, I didn't know that I could have multiple server sites federated with my portal. It's not a one-to-one, it's a one-to-many. So you have full flexibility, But the different server roles have different recommendations on scaling out, scaling up, that I'll go through here in just a second. So know your server roles. We have the 4 main server roles that I'm going to talk about in this particular session. This is where the session gets a little bit text heavy on the slides. That's mostly a cue to myself, but also because I want you to be able to take these slides when you get back to your offices and make use of them. So they're a little bit of a reference doc, a cheat sheet for what's also in the documentation itself. The GIS server is what all of you already have today. This is traditional ArcGIS Server. And you can create as many server sites for the GIS server as you need, as many or as few. And like I said, it can depend on exactly the types of services that you have, the different SLAs you may have. Maybe there are certain sets of services that absolutely just have to be up and running 100% of the time. You want to dedicate some infrastructure and resources to those. Maybe some are slightly less important, so they only get a single isolated machine that can do whatever it is it needs to do. Isolating GP from routing, from map services, completely up to you to understand your usage patterns. Image server is a little bit different. For traditional image server functionality, what used to be image extension for server, meaning publishing dynamic image services from Mosaic datasets. It's similar to the GIS server itself. If you have different sets of dynamic image services that have different SLAs, or simply you want to isolate them from each other, you can create as many sites as is appropriate for your setup. For the new raster analytics functions, what we've introduced at 10.5, there can only be a single site that's designated as this is the site where raster analytics functions run. So that site is something you have to scale up or scale out to give additional resources. We don't today in the product have a way to say, well, some raster analytics jobs go over here, other raster analytics jobs go to this other site. All raster analytics jobs goes to one specific site that you point out. The same thing is true for GeoAnalytics. There's one site for GeoAnalytics within the deployment. And that site can be scaled up and scaled out as needed. You tell the system, this is the site where GeoAnalytics jobs will run. And then finally, just because we need to have as many different combinations as we can, GeoEvent, you can have as many sites as is appropriate for you, depending on how many streams, how big your machines are, how many events per second they can process. If you do need to scale out because you have many separate streams and you can't handle them all on a single machine, you can add additional sites. At 10.5 and prior, the strong recommendation is to use single machine sites. So if you're in the GeoEvent realm, that's an important note. That's a bit of a change in recommendations from previous releases, so I do want to make you aware of that and point it out if you hadn't seen it already. So just before I move on and talk about the individual sites, I want to show what I meant by being able to designate a server site as a raster analytics or GeoAnalytics. So this is actually the system that we used for the plenary on Tuesday. This is the system Lauren was doing her demo of GeoAnalytics up against. So in this setup, I have 2 separate server sites federated with my portal. The reason the second one is showing as an exclamation mark is because it's running in the cloud and I shut down the machine to save money. We have 2 different sites here, one running, one not. When you look at the hosting server options here, you can see in my dropdown I have those 2 sites available. I can say this particular site is my hosting server site. If we scroll further down, new at 10.5, you'll see these 2 options. One's for GeoAnalytics, one's for raster analysis. Here, for GeoAnalytics, I selected the other site and said, this is my GeoAnalytics site. So this is where the one site you want to use for that purpose is shown. And breaking my own recommendations, I also have that same site set up for raster analytics. It's a tightly controlled demo environment. So that's how it actually shows up within the user interface. Here I'm designating a site for a specific purpose. So let's take a look at Image Server. I already alluded to this a little bit. Image Server has two distinct capabilities. The traditional dynamic image services, you have large collections of imagery set up with mosaic datasets and the ability to publish those out as image services and perform on-the-fly processing. Just in time as a request comes in, we read the pixels, do the mosaicing, apply the raster functions, and return an image to the client. It's not persisted anywhere. New at 10.5 is raster analytics, which you also saw demonstrated on Tuesday during the plenary. Vinay showed how we could process massive amounts of pixels through large collections or simply high resolution or large geographies. This is about performing that analysis at source resolution, not just the display resolution of a client coming in, but at source resolution and then persisting the results on disk. So this is where you can use multi-threaded distributed computing and use a raster analytics site for that. So one thing to consider here is, do I want one image server site doing both of these things, or do I want to split those things apart? The simplest option is, of course, to just have a single site. You have all the components of the base deployment from before, your web adapters, your hosting server with a little house icon, portal, the data stores. And now we've simply added one more ArcGIS server site, a logical entity for those different image servers. Going beyond that, you could take that extra step and split dynamic image services off from your raster analytics features. Often this would be the recommended approach. Because again, while you're doing raster analysis, while you're processing all of those pixels, that is designed to perform as fast as possible and take up all the available resources. You most likely don't want to have that impact all of your other running dynamic image services. GeoAnalytics can be compared to raster analytics. But there are some very specific requirements and some recommendations that I want to highlight, because GeoAnalytics is brand new. So I want to make sure that you're all aware of some of those details. As I mentioned, there's just one site for GeoAnalytics. So that one's easy. You don't have to worry too much about whether you want multiple sites or not. To set up GeoAnalytics server, you also have to have the spatial temporal big data store within your deployment. So when you install ArcGIS Data Store, that's the software component, you get a little wizard that says, do you want relational, do you want tile cache, do you want spatial temporal? Part of the base deployment was relational and tile cache. Now we have a feature that requires spatial temporal. Trick here is spatial temporal big data store, while in this case I'm saying it's used by GeoAnalytics, is always hooked up to the hosting server. ArcGIS Data Store is always connected to the hosting server. And through the federation and the trusted relationship between all the different components, GeoAnalytics will automatically use that. And we'll see why that is the case here in just a second as we get to GeoEvent. Spatiotemporal big data store has a completely different usage pattern than a traditional RDBMS. It can use even more memory if you believe that's possible. We recommend using at least 16 gigs of memory for your spatiotemporal big data store, and a maximum of 64. Quirk of the technology. It doesn't scale beyond 64, so that's just a waste at that point. You can add multiple nodes of the spatial temporal big data store. Whether you want multiple nodes for high availability, having copies of the data across multiple nodes, but also for scaling out. The more nodes, the higher throughput you can push into the data store. So if you have large amounts of imagery or observation streaming in through GeoEvent, or you have large amounts of GeoAnalytics servers writing results back out, you may need to scale out your spatial temporal big data store. Now the next question for GeoAnalytics is, how many machines do I need? And my answer is, it depends. And I'll just leave it at that. One thing to truly understand is that it does not always equal faster processing time by throwing more hardware at it. That's why it depends. It depends on the size of your data sets. It depends on how fast you want it to go, of course. But it also depends on where does that data come from? What's the format? Are they CSV files, or are you connecting up to HDFS or Hive? Can you actually stream the data from wherever it's sitting fast enough to keep all your machines busy? If you're bottlenecked on your network, it doesn't help to add additional compute power because you can't actually get the data to the compute. Lots of different things to take into account there. But I do want to make the point that you don't necessarily have to have hundreds of cores or many, many different machines. In fact, that was the point we were trying to convey with Lauren's demo on Tuesday. As a desktop user, or performing traditional desktop style analysis, a single machine of GeoAnalytics can actually provide a huge amount of value. She was able to process through 54 million records worth of CSV-based data in about 4 minutes on a single 8-core machine. So depending on what kind of data you have and your scenario, you may not need anything more than a single machine. If you need to scale beyond that, you have to look at your data and do some proof of concepts. So the simplest version of a GeoAnalytics setup looks like this. Again, we have the components from our base deployment. We've added the spatial temporal big data store sitting off on the left, and we've added a single machine of GeoAnalytics. This can get you really, really far. Start with this. It's not complex. There's no huge system architecture that goes into figuring this out. And see how far you can come within your scenario. After this, the next step is to scale out that GeoAnalytics server side. And that's where it can get complicated, depending on what it is you need to do, how much data you have, how many concurrent jobs you need, and so on and so forth. See, everybody's taking pictures. Let's move on to GeoEvent. So GeoEvent Server provides the ability to create those GeoEvent services and also stream services for visualization purposes. As I mentioned, the strong recommendation for 10.5 and prior is to use a single machine site for GeoEvent. You can have multiple single machine sites, but within each site, stick to one. That means that each machine or each site needs to be powerful enough to meet the peak demand that you're going to put on it. However many events per second, observations streaming in, you need to be able to handle on that one machine for that set of streams. In other words, if a single stream of input data is too much for your machine to handle, you need to scale that machine up as opposed to scaling it out. To handle multiple streams, you can scale out by adding additional sites. When you're archiving large amounts of data from GeoEvent, that's also the spatial temporal big data store. But it's not a requirement in that sense. If you have fewer than a couple of hundred events per second, that can typically be handled by a traditional RDBMS as well. So it's your choice. Do you want to archive into your Oracle, your SQL Server, or do you have something beyond what you can scale to meet there? and then you can use spatial temporal big data store. It means there's a couple of different options for GeoEvent and what your deployment can look like. The simplest version is just the base deployment plus a single machine GeoEvent. From here, you can write to the relational data store within the base deployment or your external database, enterprise geodatabase of choice. Your own SQL Server, your own Oracle, Postgres, the whole list. Going from here, you might just add spatial temporal big data store. Single machine GeoEvent, but writing our archive of observations to spatial temporal big data store. The next step from here would be to expand out with additional GeoEvent server sites, one machine at a time. At that point, you're almost certainly in the category of wanting to write all of those observations to the spatial temporal big data store. You very quickly can saturate a traditional RDBMS. All right, some key takeaways. How am I doing on time? Much faster than anticipated. Some key takeaways. ArcGIS Enterprise is designed for the federated server model. There's lots of newer functionality, such as raster analytics and GeoAnalytics, that require it, but there's also something much more down to earth, which is simply using ArcGIS Pro. There's lots of new capabilities in Pro, and I want you to be able to take advantage of that. For that, you have to have the federated server model. In other words, it's not just server, it's the whole ArcGIS Enterprise installation with the base deployment in place. Understand what the base deployment means. Those different components, how to scale them out, when to scale them out. Don't necessarily make it too complicated too quickly. It doesn't have to be hard. I know it can seem overwhelming, at least based on some of the questions we get. Once you are ready to go beyond the base deployment with GeoAnalytics or some of the other server roles, look at the information that I went over here and talked about. What are the individual roles? How do they scale out? What do I need to keep in mind? What did I start off by saying? Don't panic. Start small, start with the base deployment. You can start on a single machine. If you're setting it up yourself, that's by far the easiest. If you're setting up in a different environment using an automated technology, that is still a super quick, easy way to get started. As you plan out for your organization a production environment, ask yourself, will I need to scale beyond what I can handle on a single machine? If so, I should start off with a multi-tier deployment simply for ease of scaling out further down the road. All right. For once, I didn't go long, which means I have time for questions. Hopefully this was helpful. I'm really happy you showed up here this afternoon. I have about 10 minutes for questions. There's usually lots of great questions about system architecture at this point. But thank you. All right. Question down here in front.
You get the hosting server, which is your primary sort of core deployment there, and then you want to add another GIS server to your mix just to offload processing, for example. Does it automatically happen, or do you have to say, okay, hosting server, you are no longer responsible for processing?
So I'll try to restate the question. I start off with my hosting server, a single site for both hosting and traditional GIS server duties. Now I add a separate GIS server site. How do I now tell the system to start using that separate site for certain things? For that, you will have to publish your additional services to that site. Explicitly say, this set of services goes over here. Hosted services always go to the hosting server, by definition. Everything else, things you're publishing from ArcMap or Pro, you have the explicit choice of saying, this map service, this feature service, this locator, this GP service goes on this particular site.
Is the licensing for this administered by the core, or is it by the
Is the licensing for this administered by core or named user? The server roles are all licensed by core, by capacity. The GIS server, GeoEvent, GeoAnalytics, and the image are all by capacity, by core.
The functionalities of ArcGIS Server, is it a different install, or is it just that I've been granted this, I'm in this side of the granted this role, therefore I'll behave as though
I'll try to restate the question and tell me if I understood you. Is there multiple different installs or ways that I get the different capabilities? There's one software installer. You download the ArcGIS Server installer. You run that installer. And then the last step is I need my license file. Once you give it the GIS Server license file, now it has GIS Server capabilities enabled. You can now publish map services, feature services, and so forth. If you give it a GeoAnalytics server license, it now can do GeoAnalytics. It can't do anything else. And that's actually a new concept at 10.5, right? If you connect with, let's say, ArcMap to a GeoAnalytics server and try to publish a map service, it'll say, no, that doesn't work. Yeah.
If I need both types of data stores, which I'm understanding each requires a hosting server, am I two ports in that? Three ports?
Am I what?
Port for each hosting server?
No, so the question is, do I need a separate portal for different hosting servers, different data stores? The answer is no. There's a single portal that has one or more different ArcGIS server sites for different purposes. The first such site is the hosting server site itself. All of the data stores connect up to the hosting server site. The different data stores are managed from within the system. So all of the other machines within the whole topology are automatically aware of those data stores. GeoAnalytics server, when it gets connected up, simply knows, because it's part of the overall system, that there is a spatial temporal big data store somewhere off on a different machine.
Just kind of jump on that question. If I have a hosting server that's inside the DMZ and wouldn't be able to see inside of the hosting portal, would that cause issue?
If I have a hosting server in the DMZ and it can't see inside the network, would that cause a problem? Depends on where your clients are, where the other components are. That can get complicated. The system is designed that all the components can see each other, right? They need to be able to see each other. Then your clients need to be able to access the REST endpoints of each one of the server sites. So any server site has to be accessible to the end clients.
So let's say there's a situation where I want to be able to publish vector tile patches to a machine that's out in the DMZ for external users outside of the organization. In that particular scenario, my understanding is that vector tile cache can only be built if there's a federated server portal relationship.
I'll restate. So publishing a vector tile layer is an example of something that requires the base deployment. You need your portal, you need your hosting server, and so forth. Publishing a vector tile layer is simply handing over the tile package to the system, and it gets automatically made available as a layer. We can probably finish that one offline and draw some lines on a whiteboard. I like drawing on whiteboards. All right. Question off on the side.
If I want to go to scale out spatial temporal nodes, what's required for licensing? What's another base deployment per node?
So the question is, if I need to scale out at the data store tier, in this case the spatial temporal big data store, but relational or tile cache as well, what do I need from a licensing perspective? Nothing. There's no additional licensing associated with any of the data store components.
So then you can grow unbounded as long as I've got one license for the base deployment.
It can grow unbounded, yes. Because why does it need to grow unbounded? Well, because you have GeoEvent or GeoAnalytics sitting in front. So there's no additional licensing associated with it. Last question, and I think we'll wrap it up.
My organization uses CityWorks, so we have the CityWorks server routing extension on our server right now. Would that fit into this deployment as well? Just put that on the server.
So the question is, you're using a partner solution, in this case CityWorks, and they have an SOE, and will that fit in here? I hope so. I don't know the CityWorks solution specifically, so I can't answer that definitively. But to the extent that it's an SOE that runs on top of the GIS server, yes, you can install SOEs and use that within the federated model. Okay. Thank you so much.